to the math tutor. We are starting a series of videos on discrete mathematics plus the standard. So, and we start with set and relation. Set and relation. So, what is a set? Set we know from school level standard कि ये जो सेट के बारे में सबको पता हो कि प्लस थ्री स्टैंडर्ड के कोई भी स्टूडेंट को सेट के बारे में थोड़ा बहुत तो आइडिया होगा ही होगा। सो हम लोग क्या करेंगे, सेट को थोड़ा ओवरव्यू कर लेंगे और जो इम्पोर्टेंट थ्योरम है और जो इम्पोर्टेंट डेफिनेशन है जो है वो सब कुछ देखेंगे, बट थोड़ा ओवरव्यू करके चलेंगे और रिलेशन जब स्टार्ट होगा उसको डीप लेंगे। ओके, सो how we represent a set? Set representation. We generally represent set in two way. Okay, first one is roster form, and second one is set builder form. Okay, in roster form we generally represent write every element of the set in a closed bracket. Okay, so for example, I am writing the set of natural number 1 2 3 up to infinity. So this is the set of natural number, and if I write this in set builder form, I write x such that x is a natural number. Generally we symbolize set as capital alphabets. Okay, set of natural number can be represented as capital N. Similarly, integer can be represented as Z. Rational number are represented as Q. If I write Q in set builder form, I write P by Q. Every element of the rational number are in the form of P by Q, where P and Q are integer and q not equal to 0. Similarly, irrational number can represent a q prime and real represented r, and complex number are represented as c. Okay. Complex number are in the form of a plus iv, where a and b are real number. And I is the root over of minus 1. So this is all about the representation of a set. We generally name the set with capital alphabets and the 0. Then we start what is belongs to. Belongs to or is a element of. Symbolize this as this. Okay, when an element is belongs to some set, you relate them with this symbol. Okay, for example, if I write a set A as 1 2 3 4 this. Okay, so I write 1 belongs to A, similarly 2 also belongs to or is the element of A, 3 belongs to A, but 4, if I write 4 belongs to A, this is 0, because here bracketed 4, that means if 4 this term, this element is itself a set. Okay, this is not a single 4, so this will be wrong. And what will be the right form of writing this? This is the right way to write. Okay, this is all about belongs to or is a element of or not belongs to. So we can write 4 not belongs to A. Okay. Then when a set are equal, equality of a set. Now, so first we discuss subsets. Okay, then we go to equality. So, what is subset or superset? Subset and superset. We say A is a subset of B. We say A is subset of B and write A subset of B if and only if every element of A contained in B. Okay, and also if A is subset of B and A is not equal to B, then we say A is proper subset of B. Okay, and denote it as, and denote this as A subset not equal to B or A simply subset B. Okay, so what is a subset? When A is subset of B, if every element of A is a element of B. Suppose B has element 1, 2, 3, 4, 5 and A has element 1, 2, 3. Then we write A is a, here these two sets are A, every element of A is contained in B and A is not equal to B. When two sets are equal, if every element of A, if a number of element and if every element of both sets are equal. Okay, for example, we will do this equality of set in our next section. So this set are not equal because this contain 3, 4 and 5 and this only contain 1, 2, 3. So since A is not equal to B and every element of A is contained in B, so I say A is a proper subset of B. Okay, and superset is another way of writing subset. Okay, similarly, if A is subset of B, I say B is a superset of A. This is the just the same thing. Okay. Now, what is the equal set? Okay, equality of a set. Equality if A subset of B and B also subset are equal to A. If every element of A is contained in B and every element of B is contained in A, then I say A is equal to B. A set equal to B. For example, if I write a set 4y2, 6y3, 2 pi by pi is equals to the set of 2, because this, on simplifying, this is also 2, this is also 2, this is also 2. So this every element is 2 and this contained in this set and 2 is also contained in here. So these two sets are equal. Also I can write 1 2 1 can be equals to 1 2 can equals to 2 1. All these are equal set. Okay, then we have a theorem. Okay, then we have a small theorem. We have, suppose for a set A, okay, oh I left something, okay, कुछ छूट गया है. So इस पे जाने से पहले, थ्योरम पे जाने से पहले, what is the empty set? What is empty set? Set containing no element. Set containing no element, and it is represented as so let's come to the theorem. Okay, for a set A is a subset of A and phi is also a subset of B. So let's start the proof. We know we have, suppose let x belongs to A. That means every element of A is contained in A. So it is obvious that A is a subset or equal to A. Okay. Now for proving this, phi is a subset of A, we use the contradictory method. Let phi is not a subset of A. This implies that there exists some x belongs to phi which are not in X. But this is a contradiction that phi is an empty set. Since phi is empty set, there is no element, so you cannot find any X that belongs to phi, which is a contradiction. This one like that, phi is subset of. Next thing was the power set. What is the power set? Power set is the subset of set of subsets. Okay, suppose power set of A is the set of all subsets of A. For example, if A set contain only element A, okay, then power set of A is equal to phi. Phi is the obvious subset of every set and A. If A contain A and B, then power set of A will be phi A B and AB. So this is all about power set. we find the number of elements of a power set is by the formula. Okay, suppose if number of elements of A is P, then number of elements in power set of A is 2 to the power P. With the same important formula. Next, we will discuss the operations on set. Set operation. Okay, that is union, intersection, and difference. And then we study about symmetric difference, then De Morgan's law, and this is and that completes the set theory. Okay, so in the first operation, set operation was union and intersection. So union means that is collection of elements of two set. That is union of two set. What we mean? Sorry. Union means union of A and B. Union of set A and B is written as H A union B and is the set of all elements containing A and B. And intersection means section of A and B is written as A intersection B and is the set of elements that are containing both A and B, that are in both A and B. ओके, सो यूनियन में क्या होगा, वो एलिमेंट लेंगे जो दोनों सेट का सब एलिमेंट लेंगे. बट इंटरसेक्शन में क्या होता है, जो एलिमेंट्स दोनों सेट में होते हैं उनको लेते हैं. फॉर एग्जांपल ए सेट H A B C D E and B is D E F and G, then union will be A B C D E F G and intersection will be A B C D E sorry intersection में क्या होगा, ओनली कॉमन एलिमेंट लेंगे जो एलिमेंट दोनों सेट में, तो जैसे कि D एंड E दोनों सेट में है तो इंटरसेक्शन में D और E. Now union of A union phi set में, if I write this phi, it represents the empty set phi for no element is there. So union of A union phi will be A. But if I write A union this means that set, this represents a set for phi is a element, so this will be A B C D E and phi. Okay, similarly A intersection phi, there is no element in common between a and 5, so this will 5. And okay, this is all about union and intersection. Oh, now we have important representation. Suppose when I write, I have multiple number of sets. Okay, I have here only a and b. I am to understand the concept how I am writing a and b. But for some question or problem, there are many sets. Okay, there are infinite number of sets also there. So when I will represent more number of sets, we represent in this way. Okay, a1 union a2 union a3 union, suppose n number of sets are there. Okay, so I can write this as union of ai is I equal to 1 to n. Similarly for intersection also, if a1 intersection a2 intersection up to an, I can write I equal to 1 to n a. Okay, so I have 10 number of sets. Suppose a1 a2 up to a10, I write union of I equal to 1 to 10 ai. Okay, similar for intersection also, I can write like that. Now I have some properties and problem on union and intersection. Okay, suppose for any set a, p and c, okay, these are not problem, these are properties actually. Okay, properties union and intersection. First one is commutative property. These are some obvious property. Okay, a union b equals to b union a, or a intersection b equals to b intersection a. Similarly, associative also there. But we do a problem that is commutative, that is distributive property. Okay, a union b intersection c equals to a union b intersection a union c, or a intersection b union c equals to a intersection b union a intersection c. Okay, we will prove this one, and this is a homework for you. Okay, so, and I have another homework for you. Okay, let's do it. The test if these two are equal or not. A intersection b union c equal to a intersection b union c. Test whether this is equal or not. Okay, also test that associative property of intersection. Okay, a intersection b intersection c equals to intersection b intersection c or not. Okay, test this, check. We'll prove this one. Okay, and these two question you can do it by taking examples. Okay, when these are not equal. Okay, and we will when we have to show that these are not equal, so we have to give a counter example. But when we have to show these two are equal, we have to prove theoretically. So we will prove this one theoretically, and then we have a theorem. Okay. So when two sets are, this is a set, left hand side is a set and right hand side is also a set. So when two sets are equal, if when two set A and B are equal, if A is a subset of B and B is also a subset of A, so we have to prove in both ways. Okay. So first I am taking element in left hand side, and then show that that element also contained in the right hand side. Okay. So let X belongs to A intersection B union C. Okay, that means X containing A and also containing B intersection C. This implies that X belongs to A and X belongs to B union C. Now, since X belongs to B union C, that means X may contain in B or contain in C. This implies that X contain in this implies X contain in B or X contain in C. This implies that X belongs to A and X belongs to B or X belongs to C. In any way, if X belongs to B or X belongs to C, in either way, that implies I write there as A, that implies X belongs to A and X belongs to B, or X belongs to B, A, or X belongs to C. Sorry, and X belongs to C. Okay, X belongs to A is the obvious. Is from this. Okay. And X belongs to B or X belongs to C. So I am taking these two or these two. So in the first two term, X belongs to A and X belongs to B. That implies X belongs to A intersection B. Or, and from last two term, X belongs to A intersection C. That implies X belongs to, or this implies that X belongs to this, or this X belongs to this. X belongs to A or X belongs to B. That implies X belongs to A union B. So here also similarly I can write X belongs to A intersection B union A intersection C. That implies that I am taking element, I take an element, arbitrary element in left hand side, and that element is contained in right hand side. So left hand side set is every element of left hand side is contained in every element containing the right hand side set. So this implies that A intersection B union C is subset of A intersection B union A intersection C. Now again, I am taking an element in right hand side. Let X belongs to A intersection B union X A intersection C. That implies X belongs to either A intersection B or X belongs to A intersection C. This implies that X belongs to A and X belongs to B, or X belongs to A or X belongs to C, which I can write that X belongs to A or and X belongs to either B or X belongs to C. Because 2 times A, I can write X belongs to A once. This implies that X belongs to A and This or can be written as x belongs to B union C. X belongs to B or x belongs to C. That implies x belongs to B union C. So this can also written as x belongs to A and x belongs to this. So x belongs to both A and B union C. So x belongs to A intersection B union C. This proves that I am taking element in right hand side and that contain in the set left hand side. So right hand side A intersection B union A intersection C is a subset of A intersection B union C. So from equation 1 and 2, left side is a subset of right side and right side is a subset of left side. So this both sides are equal. A intersection B union C equal to A intersection B union A intersection C. Okay. Now I have an important theorem. For set A and B, A and B, A intersection B is equal to A if and only if A is a subset of B. So when there is written if and only if, we have to show in both ways. That is, first we take A intersection B equal to A and prove that A is subset or equal to B, and then take this and prove this. Okay, so first, given that we take A intersection B is equal to A. Okay, and let's take a element in A that x belongs to A. That implies that x belongs to A intersection B, which implies that x belongs to A and x also belongs to B. This is why I am taking an element in A that belongs to B. That implies that A is a subset or equal to B. So this is the first part. This completes the proof of the first part. Again, conversely, I am taking element in right hand side. I am considering right hand side. We have A subset or equal to B. Okay, let x belongs to A. This implies that since A is subset or equal to B, this implies that every element of A is contained in B. So if x contained in A, that implies that x also contained in B, which implies that x contained in A also contained in B. So this implies that x contained in A intersection B, which implies that I am taking an element in A that also contained in A intersection B. Oh, sorry. This implies that A is a subset of A intersection B. Here, we have to show these two sets are equal. So the condition of equality will be used here. That is, if A and B are equal, when these two sets are equal, if A subset of B and B subset of A. So we have to show that in both way. Okay. So I take an element in left hand side. So that is A. So I have taken element x belongs to A and shows that taken an element in right hand side and shows that the element also present in the left hand side A intersection B. X is present in the left hand side. So this shows that every element of right hand side present in left hand side. So A is subset of equal to B. Again, let's put this equation 1. I am taking an element x belongs to A intersection B. Summarize that x belongs to A and x belongs to B. Since what do I have to prove here? Prove here this. This implies that this proves that if x belongs to this, that implies that x belongs to A also and B also. That means x also belongs to A. X belongs to this set implies that x belongs to A set also. So every element of this A intersection B is an element of A. This implies that A intersection B subset of A. So from 1 and 2, A is equal to A intersection B. So this proves our theorem. So what you have to do? You have to do these three problems. Okay. You have to check this one, this one, this one. You have to prove this one theoretically and these two one by taking example. Okay. For any doubt and query, please comment. Thank you.